Okay, matrices test. My word of advice is to go slow and steady because there's so much room for small mistakes, okay? Okay, so 2a minus b is the first question. Okay, so I'm going to write it like this. So 2 of these, so that's 42 minus 133. So that's what I did, 2 of that minus that. Okay, so this one would be 2 times 56. So 112 minus 210. 112 doubled minus 210. Okay, keep going in that pattern, and then we can check that our answers are the same. Okay, so there's your final answer. Hopefully we're all matching. Okay, 2 is multiplication. Okay, so let's just talk about the order here. So what kind of order is A? It's a what by a what. So always remember RC, Rapid City, the city. So we have how many rows? 2 by 3 columns. And B has 3 by 2. So what's the only way you can multiply if those are the same? And then my final will be a 2 by 2. Okay, so if you need to, please make sure you understand all the combinations. Okay, so what are all the combos? So this would be a row 1, column 1. This would be located row 1 in column 2. So this would be row 2 in column 1. And then this would be row 2 in column 2. Okay, so you have those 4 combos. So for instance, what does row 1, column 1 look like? Row 1, column 1. So you have to do 3 plus 0 plus 2. Okay, so then here says I'm going to go row 1 and column 2. So I got to match, match, match. So 1, negative 2, negative 3. Okay, can you do the last 2 matchups on your own? So obviously if you're not getting a perfect match, something's going wrong, right? Okay, does that make sense with all your combos that you're doing, right? And follow along. I don't know if you need to borrow my highlighters or rulers or whatever so that you can make your matchups like that. Okay, everybody agrees with the same answer? Okay, so this is just algebra. So if you wanted to solve for A, we could move this to that side, right? So we could minus this matrix over. So if we minused it, so what is 6 minus 2? 4. 0 minus the 12. Be careful here because you're minusing a negative 10. So that would be 8, right? Negative 2 minus negative 10. Is that good? And same thing here, 5 subtract negative 3. 8. And then I would still have that. So this is just algebra again. So then what would I do? Divide both sides by negative 4. Okay, so you're just doing exact algebra steps that you've done in the past, but just with a matrix. So I moved it over and divided. Okay? All right, everybody's favorite. Okay, row reduction method. So remember with row reduction, your goal is just those 3 zeros, and then that's it. Okay, so let's start by just writing down 1, negative 3, negative 7, 10. Okay, I'm not gonna lie, there's always somebody who makes a mistake on the test about copying down something wrong. Okay, so even go back, did I copy it? Did I copy it? Okay. Okay, the first one that gets attacked is that. So I'm already just going to rewrite row 1 and row 3. I'm going to rewrite them because they're not going to move. Just the second row is going to change.
Why are we attacking that one? Oh,
because the goal is to do it this, this, and then this. Those are the goals. So that's the first one. Okay. So I'm going to do what? Row 1 plus row 2. Is that good with you? I'm going to make a 0 that way. Okay, so I'm going to add these and I get a 0. So that's the goal. Okay, negative 3 plus 5. Negative 7 plus 6. 10 plus negative 21.
Why are we doing row 1 plus row 2?
Because I need to make a 0 out of this position.
Oh, okay.
So if I'm going to add 1 and negative 1 together, that does it. Okay, so here's where I am. So which is the next attack? This one is the next 0 in the triangle zeros. Okay, so I'm going to, if I'm going to attack that one, I'm going to rewrite the first, and I'm going to rewrite the second.
This guy's writing so big.
I don't know what I was doing.
Yeah.
He'll probably need one.
I won't need one.
Okay, so this one is going to get attacked. So again, I just copied down row 1 and 2 completely. Okay, how can I get this to be 0? What kind of math? Row 1 plus row 3. If I add that, that's going to be 0. Ooh, I got a bonus.
What?
Woo, a bonus. Don't have to do anything else now on that one. 3 and 3. Okay, so normally I would need to attack that on another step, but it was a bonus, so I'm done. Look at me, I got my triangle of zeros.
I
don't know how to do it without the bonus.
You just attack that one again.
But then how do you keep that one at 0?
but you would have to do some kind of math with row 2 and 3.
Oh,
You have to do row 2 and 3 on that one, because if you were to do row 1 and 3,
good mess up.
you would deactivate a 0. Like you would put a 0 back to a number. Yeah, if you're ever putting a 0 back to a number, that's not the right process, okay? Okay, so we're done. So we're gonna go starting bottom up. So the 3z equals 3, so that's the bottom line here, right? Because everybody knows this is the x stuff, this is the y, this is the z, this is just a number, right? 3z equals 3, so z equals 1. Okay, work your way up. So this would be 2y subtract 1z equals negative 11. 2y minus a z equals negative 11.
Where's the 2 up?
This.
Oh, yeah.
This is no x's, 2 y's, negative 1 z's equals negative 11. Okay, last, work your way up to the top. So 1x minus 3 y's minus 7 z's equals 10. For what I'm doing here? Yeah, because you can't solve for x in these ones at all.
No, but like if you go up to the top, can you not go up to the top?
Oh, yeah, yeah, like if you just plug into the one, like something up here. Yeah, that's fine too. I think I answered like what you were looking at. You just, yeah.
Just a second.
Okay, what if I didn't want row reduction? So this was row reduction, but what if my question, what?
Someone has a question.
Am I supposed, is it appropriate to put on YouTube video if I open it?
Where did you get the Z from?
The
Oh,
Z?
I see now.
This one. 3z equals 3.
Oh, yeah.
Okay, we're going to pretend I didn't do any of this work. And we're going to go into Gauss-Jordan from that step on. Or you want me to stop and pause that?
He was too busy
Got it.
asking that one question.
Okay, you're getting one of them, right? At the bottom, you get that. And then you plug in moving up, right? Because this is, yeah, plug in, da-da-da, now you have a y, now you plug in, get a z, x. Okay, very similar to what we did in grade 11, right? The 3 equations, we funneled down, plugged in, funneled back out. Okay, so we're going to continue to Gauss-Jordan. So I'm going to continue from this one, moving on. Okay, so Gauss-Jordan says 0 it, 0 it, 0 it, then 1 it out. So I'm going to go row 3 divided by 3.
Oh, because you want it one.
I want to 1 it out. Okay, so if I follow the pattern, we have our 0, we have our 0, we have our 0, we have our 1. We're done all those ones.
Can you give us that chart like that?
No. 0, 0, 0, 1.
Is it always that?
Yep. So what's our next maneuver? 0, 0, 0, 1. Now I need to do a 0. So I need to attack that. So I'm going to copy the top and the bottom. Okay, when you're working with this now, should we do row 1 and 2 together somehow, or row 2 and 3? We have to pick row 2 and 3. Why?
You can't mess that up.
You can't mess up your 0, because if you put row 1 and 2 together, somehow you're deactivating your 0 and you're going backwards again. Okay, what do you want to do with those? I think just add them, right? So row 2 plus row 3. Man, I'm giving you guys some easy ones here. Okay, so 0 plus 0. 2 plus 0. Negative 1 plus 1. 0. Negative 11 plus 1 is negative 10. Okay, so we did a 0, 0, 0, 1, 0. So what do we have to do next?
Make that a
1 it out. So I need to 1 it out. So row 2 divided by 2. Row 2, you're going to divide by 2. So 0, 1, 0, negative 5. Done. Okay, now which one of the positions would we go to next? Remember, your zeros make a horseshoe.
Top.
So we have to follow that order. So 0, 0, 0, 0. So we're on
Top, right?
that one. Okay, so what I'm going to do here is I'm going to copy the second and the third row. They're actually like finalized. They will never move now. Okay. What do you want to put it with, the second or the third? I think we have to do third, right? Okay, row 1 plus 7 row 3s. Would that be good? Row 1 plus 7 of those. Going back to my progression, I am now done that 0. So now what's next? Another 0 there. So I'm attacking, there's my attack. So again, I'm copying down row 2 and row 3. So I know it fills up a lot of your page, but a lot of it is copying as well, right? So make sure you're precise with copying. Okay, what am I doing here? That plus 3 of those. Row 1 plus 3 row 2.
bonus on the line.
So 17 plus negative 15, right? 17 plus negative 15 is 2. Okay, we're done that. So the next step would be to 1 it this out, but it's already done. It's a bonus. I feel like I'm nice enough that I always give you that one bonus, the 1 it out at the end. Okay, so what can you conclude when it looks like this? What does this mean? 1x equals 2. What does this one mean? 1y equals negative 5. Did we match our row reduction answer? Yep. Okay, so slow and steady, right?
It's the choose.
If,
Can you choose that? Which one to use?
no, on your test, I'm gonna have a question that's a row reduction one, and I'm gonna have a separate one that's a Gauss-Jordan,
Why
so.
is it cost Jordan?
Because that's the name of the person.
If we're doing the Gauss-Jordan one, do you have to do row reduction first and then continue on, like you can
Yeah, Gauss-Jordan always starts as a row reduction, because like the first 3 steps of row reduction are 0, 0, 0. The first 3 steps of Gauss-Jordan are 0, 0, 0. Okay, on your test, I'm not going to give you funny business. Your answers are all nice, pretty integers, okay? So if you're getting a decimal, go back. Okay, I'm not going to give you funny things like that, okay? Okay. So this is a formula for an inverse. So I will give you that formula. Okay? Okay, so here we go. We're going to find the inverse to this. So 1 over AD, so that would be 4 times 6, 24, minus BC, 14. And then the 4, 6 have to flip-flop. And then the 7, 2 have to negate.
Will this formula be in the
I will give you this formula. Yeah. Are you seeing 1/10 in the front? This is 1/10, right? So 6/10, negative 7/10, negative 2/10, and 4/10. And I know those reduce, but I don't care. I'm just going to leave them all with 10. So I times that by 1/10. So this is the inverse matrix, okay? Okay, so what happens here? So this, do you see what I did here? This is 4, 7, 2, 6. That's that part. Okay, so we had 4, 7, 2, 6 times the variables x, y equals 17, 16. I'm leaving a space for on purpose. The coefficients times the letters equals the solutions. So do you see my parts there? I just broke this down into matrix form. Okay, now here's what we're going to do. In math, we can manipulate algebra if we do something to both sides. So I'm going to times both sides by the inverse. Okay, so I'm going to times both by the inverse. Okay, do you know why I left a space and put this in front of that instead of writing it behind? Anybody know why I specifically did that?
So you can multiply.
So I can, yeah. Yeah, so I can match. Because this is a 2 by 2 and this is a 2 by 1. If I had them written the opposite way, I wouldn't have been able to do a matchup, okay? So that's why I wrote it in front of that one. Okay, now we could multiply this out, but what did we prove inverses and originals do? So if this is A inverse and this is A, what should they make when I multiply them? Identity. Okay, you can totally do it the long way, but it should equal that if you've done it right. Okay, here we go. I need you to match multiply, so row 1, column 1. Oh man, I didn't give you very nice numbers. 6 times 17 is 102 over 10. 7 times 16 is I feel like this is going funky. Did anybody get the same numbers as me? 6 times 17 is 102. Okay. Yay? Somebody the same as me? Because I feel like this is a decimal, isn't it? Decimal? Okay. Here we go on the bottom. So this one would match, so this is negative 34 over 10. And 16 over 10. Or 64 over 10.
For the top, isn't it just 102 subtract 112, not 102 subtract negative?
There, that's what I went wrong. Thank you, like that. Yeah. I was like, something is going wrong for me here. There we go. Negative 10. There we go. Found it. Thank you. I was saying, I'm not going to give you funny business, and then I was like, this is... Okay, on your test, what do you do when you have an answer and you want to see if it's right? Plug it in. So I can check this out. I could go 4 times negative 1 plus 7 times 3. So if x is negative 1, and I push equals, it should be 17. So that one worked out, and then I could do it again. Okay, so there's your conclusion. Okay, what do you think is the only thing that's left? Kramers. Okay, this is the one where there's going to be a lot of writing, so you have 4 sections, 4 big matrices. Okay. Okay, we're going to go determinant of matrix A. So I'm going to go 1, negative 3, negative 7, negative 1, 5, 6. I'm just going to write the 3 by 3. And then you start repeating. So I need 3 down diagonals of 3. And I need 3 up diagonals of 3. Okay, you will never use this triangle. So for me, when I repeat, I always just repeat 2, 1, 2.
That's how you do it?
Yeah. Okay, so let's get all of the down diagonals. So this one would be 50. This one would be positive 18. And this one's also positive 21. So the down added together is 89. So it's tricky because this is multiplication and then this is adding. Okay, now this one would be 35, 18, and 30. So 83. And then your last step is to do the downs minus the ups. And I know that I also put a test question on there with a 2 by 2 like this. So it's always the down diagonal minus the up diagonal. So a 2 by 2 is a lot easier. A 2 by 2 is just this minus this. That's all a 2 by 2 is, right? Just you only have 2. That's nice and easy. Okay. Now we're going to go determinant of the x. So what do you do with x? You plug in the solutions. So you replace the x positions with the solutions. Okay, x is replaced with solutions. You still do the same process. 3 down diagonals, 3 up diagonals. Okay, I'm gonna give you 1 minute to do that. Okay, so my down numbers were 500, 126, 441, total 1,067. My ups were 245, 180, 630, 1,055. So down minus up gives me 12. So this is my determinant x. So therefore, x equals the determinant x divided by the original. So x equals 2. Okay, we're going to do the same process with the y. So this time, don't forget to put your original x back in. Put the 10, negative 21, and negative 7 in the place of the y. Okay, so you can see I replaced now the y's with the solution, same process. Okay, I'm going to leave you to that one again. My down numbers were negative 210, negative 60, negative 49, totaling negative 319. My ups were negative 147, negative 42, negative 100, totaling negative 289. So down minus up was negative 30. Therefore, y is negative 30 divided by 6, negative 5.
Where does the 6 come from?
The original determinant. Yeah. Determinant, so I'm doing this, determinant y divided by original determinant. Okay, last is the x. So on the last one, I replaced z's with the solution numbers. Got my 3 diagonals set up. So my downs, I got negative 35, negative 63, negative 30, totaling an add of negative 128. The ups, negative 50, negative 63, negative 21. Sum of that is that. Then the determinant is the down minus the up, 6. And then 6 divided by the original, which was 6, gets me a z of 1.